So this is the 3 litre 24 valve Alfa Romeo V6 out of my 1981 Lotus Esprit S3. Known to many as the Busso engine after the designer. Originally a 2.5 litre 12 valve engine, later development being this 24 valve. They did versions up to 3.2. So this is a couple of hundred horsepower, entirely adequate for what I want. And when the previous owner did the conversion, he also built his own intake system. Now the iconic intake system on these engines is from these manifold adapter castings, is a set of chromed intake runners running to a plenum chamber on one side of the engine with a throttle body on the end. And what had been done on here was a set of custom manifolds with Triumph motorcycle throttle bodies in a downdraft arrangement with about 6-inch tall intake trumpets on them, the whole lot protruding up through the engine cover. And I will try and find a photograph if I can, but I want to be actually able to drive the car, which means it mustn't be stupidly loud. And with the engine cover having been cut, you're going to get all the mechanical noise from the engine, you're going to get all the induction roar, and there's only a single pane piece of glass between the engine bay and the cabin on the Esprit, so it really needs that engine cover to seal, to keep the noise levels down to the point where I could actually take it on a decent length trip. So, easy solution would be just to put a standard Alfa Romeo intake system back on it. The problem is those are quite hard to find and really expensive. Even finding these flanges took a while, and these are 2.5 litre flanges, which are slightly smaller porting on them, but there's not a lot in it, and I can just ease them out if I feel like it. Intake runners I've seen anywhere between £100 for a set to £100 each, and certainly a local Alfa Romeo specialist quoted me £450 for a setup ready to bolt on. It's still not quite as low. I may have ended up having to raise the engine cover. So, the current plan is to run one set of intakes in that direction and another set of intakes in that direction. And then to go back to the Triumph motorcycle solution and to use this one-piece butterfly setup from a later version of the Triumph 955 that the original throttle bodies had come from. So this will go somewhere in this orientation. The spacing on this is not the same as the port spacing on the engine, but if I split the difference, the amount that I'd have to angle the outer intakes in order to line up, there's not a huge amount in it. I'll have to build a throttle linkage between the two throttle bodies, but that's quite doable. So I'm going to give it a look, see how it's working out, and I need to make a set of flanges to go on the end of these pipes and match up with the manifold adapters, and that's what I've started doing over on the bench here. So this is a bit of 6mm plate, and using transfer screws I got these hole centers transferred from the manifold. I've got a gasket, and you can see that this is all quite asymmetric. So having got the hole centers marked, I drilled it, put in some 5.8mm holes, which is a good close fit on an N6, and I then I then screwed this to the intake manifold and scribed the port onto it. I then used this as a drill guide to transfer the hole positions onto this tooling plate. This is just black anodized aluminium out of some bit of equipment I scrapped, and the plan is I will be able to bolt this plate on, and because I've used 5.8mm holes, it's a nice tight fit with very little wiggle. This plate will get set up in a 4-jaw on the lathe. I can then dial it in until this circle is running as true as possible. It actually looks remarkably round, but we'll take an average. We'll get it looking good by eye. This is an intake manifold, not a press fit or something. But I can then bore this plate to fit the tubing, and once I'm happy, I can then make all the other plates, and having the fixture left in the lathe, all the other plates will come out the same with the bore positioned correctly. So I've got my fixture plate in the 4-jaw, and I've dialed it in, and I'm simply using a chamfering tool. Let's see if we can get you zoomed in, and the camera will cooperate on focus. So with the point of the tool almost touching, I was able to go in and visually dial it in. It's looking pretty good. And then if I turn the lathe on, and we get the noise from the inverter. And then the rather noisy rattle from a Harrison clutch, since I've not yet converted this machine to inverter control. The circle scribe from the port's looking pretty good, in fact. Let's quieten that down for a second. So what I'll do now is I will drill through the manifold plate and the tooling plate and enlarge it to the bore size of the pipe, bore it out through both. Then the manifold plate will get bored half depth to the OD of the pipe to register it. So if I don't disturb the tooling plate, I will then be able to do another 5 of these by boring both the manifold adapter plate and the tooling plate through. If for any reason I have to remove the tooling plate from the lathe, I will be able to use that bore to get it set back up again. find the step drills are actually quite an efficient way of roughing out a hole. Obviously in this case I haven't got the depth to go all the way through at the large diameter, but I've got a lot of material removed and I can swap over to a boring bar. Well, apparently the SD card was not playing ball during that machining, but we have our through bore, and I've gone with a 2mm recess to the OD of the pipe, plus a little bit of wiggle room. The pipe's not exactly round, but as I've said before, it's an intake manifold. It doesn't have to be super precision. The fit on the inside feels nice. So that is the first of 6 flanges, usable flanges I need. I'll bandsaw and linish the outer shape, but I can now take that off the fixture plate and try it on the manifold adapter.